Lab 5, power and circuits. How bright a light bulb is depends on how much power it uses. When you go to the store, you buy a 60-watt light bulb and it's brighter than a 40-watt light bulb. A 100-watt light bulb is brighter than both of those. If you remember, it turns out that watts for power turns into a joule per second. So if it has more watts, it actually uses more power, uses more electricity per second. Now I have two different light bulbs here. This one has white inside and that one's darker on the inside. And it says here, this is the old version, I'm supposed to measure them with a multimeter to find out their resistances. Well, I did a little while ago and they both read almost identical. There's actually a better way of doing that, which is this first lab here. Now, you remember that in a series circuit, the bigger resistor uses more voltage. Well, since P equals V times I, you should know that in a series circuit, they have the same current. This is for series. So the bigger volts will be more power. In other words, when I put this in here, the one that's brighter will be the bigger resistor. So let me go ahead and hook it up. Now, hopefully you can see that that one's brighter. So I'm going to call that 1. I'm going to call this big R. I'm going to call this little r. Okay, that's the bigger resistor, smaller resistor. Which bulb is brighter? R1, the bigger resistor. Are the light bulbs in series or in parallel? Series. What's the same? Current. Since P equals V times I, which bulb uses the most power? The big resistor. Therefore, it must use more voltage. Okay? Two resistors in series have the same current. The larger resistor uses more voltage, which means it uses more power. That's why the larger resistor is brighter when they're in series. Now I'm going to put them in parallel. That's why this is here, so I can do this quickly. Put them in position. Now notice there's a junction. It splits, goes through them, and comes back here. All right. Remember, let's just double check that what we saw. Brighter. Brighter. Which light bulb was brighter? Resistor 2, the smaller one. Are the light bulbs in series or parallel? Parallel. What's the same for the bulbs? Their voltage is the same. There's equal voltage going through here. Since P equals V times I, which bulb uses the most power? R2. It must have more current. So if they have the same power, or sorry, the same voltage, but this one's brighter, it's because it's letting more current through. Okay? Now, just to make this a little bit clearer, I have another one over here that will make this blatantly obvious which one is brighter in the series. But I don't remember there being very, very obvious in parallel. So here, that one's brighter, that one's barely even on. Now I put them in parallel. That one was a brighter one, right? Now that one's brighter. Okay. Once again, the bigger resistor is brighter. The smaller resistor is brighter. So, when in series, the big resistor is brighter. More voltage. Here, the smaller resistor is brighter, more current. I guess I should write same voltage. Okay. So now I got to get 3 different light bulbs, or 3 of the same light bulbs. Okay, now I have 3 light bulbs that are all equal. Make sure that all 3 light bulbs are equal resistors. Did that before you close the switch. Which bulb do you predict will be the brightest? Please pause and think about that. Why? Well, let's throw the switch and find out. That one's the brightest. And why is it the brightest? Because it has the most power. These right here are, remember, okay, so the easiest way for you to see this is that there's current going through here and they combine. So this one has the most current flowing through it. And if they're the equal resistors, but more current, it'll be brighter. Also, these two right here being in parallel are actually a smaller resistor. So these two also have less voltage than this one. This one has twice the voltage and twice the current. Okay, so let's go through here. Let's close the switch, blah, blah. So which bulb is brightest? I guess it's a B, B3, and why? Double the current. If you unscrew bulb 1, what will happen? If I unscrew bulb 1, what will happen? This one obviously will be nothing, so bulb 1 will be Na, right? Bulb 2 will get, and bulb 3, think about that, pause. Here we go. Once again, bulb 3 got dimmer, bulb 2 got brighter. Okay. I guess that should have been down here. Okay. So let's do this. It's not on. Let's finish this up, and I'll show you one more. Light bulb is brighter, 100 watt or 60 watt. 100 watt. What's the same for both bulbs? The voltage, because they're at your house. Your house is wired in parallel, so they have the same voltage. So why is the 100 watt bulb brighter? Because it is a smaller resistor and allows more current through. Okay, and if you watch my demo where I've got the two big light bulbs, I can prove that to you. Which one would be brighter if they were in series? The 60 watt. Weird, huh? Now, I'm gonna do an extension here. What if I take these and, oh, that did fit, very nice. So now I have two of them in series and one of them in parallel with another one. So let's see what happens. So which one do you think will be brighter? There you go. Okay, and if we put another one down here, that would be even brighter because again, it gets all the current. Now I don't have well, I guess I can very quickly put one in there and prove that. So this one should be the brightest, and those you can't even see again, but this gets all the current. But let's look through this. Why is that one the brightest? Now, which one has the most resistance? This one. It has 2R, and this one is only R. So since they have the same voltage from here to here, this one has more resistance, so it has less current. And then they're sharing the voltage on top of that. So whatever this voltage from here to here, two batteries, this only gets one battery worth of voltage, one battery, that gets two batteries, and because it's more resistance, it gets half the current. So this is actually getting 1/4 the power of that one.